Now we're going to compare buoyant force and also density in all the situations that we have here. We have 5 identical objects. Okay, 5 identical objects. When I say they are identical, this means that they have the same density. So all the objects here have the same density, but but the liquid used here have different density. Okay, and you need to pay attention to the statement here also. If an object is in equilibrium, the object is stationary. So let us look at the first situation here. So you can see that the object is stationary. All the 3 objects here are stationary. So this means that upward force, that is buoyant force, is equal to weight of the object, which is the direction of the weight is downward. That's why we have buoyant force equals to weight for the first situation. For this one, it is also the same. Now it is also stationary, means buoyant force is equal to weight of the object. And for the third situation, also the same. Buoyant force is equal to weight. But you can see this one, the part which is submerged in water is less compared to this one. And this one has more part of the object which is submerged under the water surface. So what makes difference between the 3 situations here is the density. So density of A, liquid here, is higher. The density of liquid A is higher than B, and density of liquid B is higher than liquid C. And also it is higher than liquid D. Okay, because you can see in this situation the object is moving down. This means that buoyant force for liquid D is less than weight. Means weight is bigger. That's why the object is moving down. Okay, it is moving down. And then look at the situation. Now the object is moving up. This means that buoyant force is greater than the weight of the object. Now we can see the difference of the density of the liquid, and the density of liquid E, this one, this liquid, is greater than D. Mean the density here is greater than density of this liquid. Now let us look here. Here is the formula for buoyant force. Since the buoyant force for the 3 situations here are the same, but the difference is the part which is submerged underwater surface. So you can see here, when we compare the part which is submerged, this one for diagram A is less than B. So B has more part which is underwater surface. So you can see here the volume is less, okay, for B, but the density should be higher. Okay, when we have less volume which is submerged underwater, so the density need to increase in order to produce the same amount of buoyant force. You should be able to differentiate the situation here, because I found that most of students, they think that when when you can see more part above water surface, they think that buoyant force is greater than weight. That is not correct. As long as the object is stationary, this means that buoyant force equals weight. In the 3 situations here, the buoyant force is still the same as the weight of the object. So you need to look carefully at this situation and try to understand, because some questions ask you to compare.